Okay, here we are with f.bf.2 learning target 2.4. So here we are now going to create recursive formulas given the explicit formula. Okay, so all these here we've got explicit formulas going on. So the thing to note, first of all, is if you're not sure what a recursive formula is, probably need to take a step back and drop down to one of our other learning targets or come in and talk to me. Okay, same with the explicit formula. To get to this point, you should know how to do all these other ones. So then, let's take a look at the explicit, what it gives us, and how we can turn that into the recursive. Okay, so with the explicit, we generally go a sub n. Now, it could be y equals, it could be f of x equals, it could be f of n as well. But for our sake, they're going to be a sub n. And we have our zero term, our starting number. And in the case of arithmetic, it's going to be plus or minus the common difference, a number, times the variable. In the case of the geometric, it's going to be times the constant ratio with the variable to the power. So this zero term here is a number, and the constant ratio or constant difference is a number. Okay? So in recursive, remember, that growth we show, because recursive deals with the outputs, it's the next output is equal to the previous output and then the common difference or constant ratio. So we're either adding or subtracting the common difference or multiplying, or in this case dividing by the constant ratio. Okay, usually we're going to multiply because rarely in the explicit, well, we really never see divide. So we really don't need the divide here. Okay, now, these have variables. We don't need to attach variables to this side. Okay, but again, with the recursive, that's only half, just because I only took care of half of our explicit. So we also, not a sub a, we also need the a sub 0, that zero term. And once we've got those in place, then we just put them in their spot. And with recursive, we always write these two pieces. Okay, that's really all we got to do. Okay, so it's not too bad. So let's take a look at an arithmetic and a geometric example first off, and then we'll go. So notice these pluses and minuses and the variables being multiplied. That tells me these first 10 are going to be arithmetic. And then looking at 11 through 20, I see multiply, and I also see powers. Okay, so that tells me that that's going to be geometric on those ones. Okay, so let's take a look at one example for each. So 8 plus 9n, so there's my growth, there's my start. So I go a sub n equals a sub n minus 1, and I don't put plus 9n, I just put plus 9. Okay, then a sub 0 equals 8. And that's all there is to it. For geometric, basically the same idea. My start, my growth. So a sub n equals a sub n minus 1. And I'm timesing by negative 6. Again, I don't need the variable. Then a sub 0 equals the negative 3. Okay? And that's all there is to it, guys. So, let's take a look. Okay, number 2. A sub n equals negative 20 minus 5n. So, a sub 0 equals negative 20. And a sub n equals a sub n minus 1 minus 5. Okay, remember that a sub n minus 1 is a term. It's all together. That minus 1 isn't really like a number. It's more telling us a position. Okay, number 3, a sub n equals negative 20 plus 3n. So a sub n equals a sub n minus 1. And our growth is plus 3, so plus 3. And we started at negative 20. Okay, so hopefully this seems pretty simple once you understand how they're both made up. Okay, number 4, a sub n equals a sub n minus 1, and then minus 2 for my growth, common difference. A sub 0 equals my starting number, my zero term, negative 27. Okay, number 5, plus 100, so a sub n equals a sub n minus 1 plus 100. That's my growth. Where did we start? At negative 88. Okay, now we could also write it as f of n equals f of n minus 1, and then my growth would be negative 20, and I could go f of 0 equals negative 1. You can do it that way. There's no problem with doing it like that. Okay, you could also, if you wanted to, do f of x, even. Just as long as we keep that same format, my growth again, -2, and then f of 0 again, 15. Okay, so there are a few different ways that you could write it, and doesn't matter which way you choose, they're all good. Okay, number 8, start of 5, growth -2, a sub n equals a sub n minus 1 minus 2, and a sub 0 equals 5. Doesn't matter which order you do it in. I can do a sub 0 first, that's 8, and then a sub n equals a sub n minus 1 minus 30. Okay, doesn't matter. Alright, number 10. Start -14, so a sub 0 equals -14. Growth plus 5, a sub n equals a sub n minus 1 plus 5. So, that's all my arithmetics. Okay, we're good there. Now let's take a look at 11. So, now it's geometric, but we still treat it the same way. The only difference is I still have my growth the same, -4. Only difference is instead of plus a number, it's times 4, so I go times 4. Okay, we already did number 12. So number 13, start is -3. Growth is times 4. Apparently we like timesing by 4 here. So times by 4. Okay, number 14, my growth is that timesing by 6. So times by 6 again, I can drop the variable, don't need it anymore. And my start is 1. Okay, could I do f of n equals f of n minus 1? Yeah, definitely I could. Then I would times by 2, and then I just go f of 0 equals 2. We can even do the f of x version. That one works too. F of x equals f of x minus 1. And I'm timesing by -3. And f of 0 equals, and it's a positive 4. Okay? All of those work. Really the one I can't use is y, because that really wouldn't work. Okay? So that's the one we don't really use. Also, if I wanted to, well, let's do this one first. So a sub n equals a sub n minus 1. My growth is times 6. A sub 0 equals 3. Now let's just say this was 3 times 1 over 6. Okay? In that case, I could write times 1 over 6, or I could realize that timesing by 1/6 is the same as dividing by 6, and I could put the division in there, and that wouldn't be a big deal. But that's only in those cases where it happens. Okay? Alright, number 18. Start at -2. My growth is times by 3. So I just write it out like that. Okay? Now number 19, notice we have this n minus 1. Okay? So what that tells us is that this actually isn't our 0 term. This is our first term. So really the only difference I have to do is go a sub n equals a sub n minus 1, still times them by 4. And then instead of a sub 0, I just go a sub 1 equals 3. And that still works. So for 20, same idea. A sub 0 equals 3. Actually, it doesn't, because it's the n minus 1. A sub 1 equals 3. A sub n equals a sub n minus 1 times a -5. Now, looking back at 19, say I wanted to still do a sub 0. Okay, then all I do was realize that that's my first term. And so if I'm going backwards to the 0 term, it'd be 3 divided by 4. So it'd actually be 3/4 or 0.75. Okay? But it would still get us the same result. So we'd still be good there. Alright, same with, I guess, on the arithmetic. Say this was actually written out as 2 times n minus 1. Again, that would just tell me that this is the 5 would be the first term, not the 0 term. And if I wanted the 0 term, then I would just have to go back and subtract or add 2 to 5 because it's minus 2. So do the opposite and I get 7. But that's really the only other thing. So there we go, guys. Again, once we understand how they're both set up, it's pretty easy to recognize those differences and then how we can jump between the two. All right, there we go, guys.